Japanese-made watches and clocks are sophisticated and durable. Japan produces more timepieces than any other country in the world. But the battle to displace the world's previous #1 producer, Switzerland, was a fierce one. Quartz wristwatch technology proved to be the weapon that won Japan the battle for supreme accuracy. Behind the creation of the quartz watch is the story of an extraordinary group of engineers who overcame numerous obstacles. Also extraordinary, a unique Japanese clock that about 150 years ago adapted and improved on Western technology. It was a marvel of pre-industrial Japanese science and engineering. On this edition of Begin Japanology, we look at watches and clocks, the technology that took Japan to #1 in the world in this industry, and Japanese interest in the tiny world inside timepieces.
Hello and welcome to Begin Japanology. I'm Peter Barakan. Our theme for today is watches and clocks. It's estimated that Japanese watches, clocks and the mechanical parts inside them known as movements account for over 60% of global production. Today we'll take a look at the history of watches and clocks in Japan. I'm in Sensoji, a Buddhist temple which is one of Tokyo's most popular tourist destinations, and Buddhist temple bells like this one in centuries past were rung several times a day to denote the passage of time. The first mechanical clock introduced to Japan was in the 16th century, although the earliest surviving clock was one that was given as a gift to the Tokugawa shogun Ieyasu from King Philip II of Spain, and that was in the 17th century. However, at the time, Japan's way of counting the hours was very different from the West, and mechanical clocks were useless unless they could be modified. Let's take a look at how it all worked.
Until Japan opened up to the West and modernized in the mid to late 19th century, the day from sunrise to sunset and the night from sunset to sunrise were each divided up into 6 time units of equal length. But since the durations of night and day change with the seasons, these units would grow longer or shorter accordingly. This is called the unequal hour system. Japan's unequal hour system had to be compatible with the mechanism of mechanical timekeeping technology from the West. So the rulers of Japan in the 17th century appointed horologists to re-engineer Western clocks. At the time, most Western clocks used a balance that acted as a pendulum to move the clock's hand at a constant rate. The Japanese horologists tried to make their own version of these. In the unequal hour system, daytime hours are shorter than nighttime hours in winter, so the hand must move faster during the day. So the Japanese clockmakers came up with the idea of changing the location of the weights to adjust the speed of the hands. By adjusting the position of the weights, the clock could cope with unequal hours. But this required moving the weights every dawn and dusk, and with the changing of the seasons, in order to tell the correct time. Experts had to constantly attend to the clocks, which was no easy task. In the mid-19th century, a revolutionary clock was invented that solved this problem. It was called the myriad-year clock. It handled the unequal hours with a hand that moved at a constant rate, while adjusting the spacing of the chapter markings on the dial. During the summer, when the day is long, the chapter markings on the upper half of the dial, representing the daylight hours, are more widely spaced. But during the winter, when the night is long, the lower half of the dial showing the night hours is more widely spaced. And the myriad-year clock performed all of these adjustments automatically. It was invented by a highly talented maker of clockwork dolls. His name was Tanaka Hisashige. Hisashige's ultimate masterpiece was this clockwork archer, and he created many other splendid dolls too. He applied his mastery of gearing used in clockwork dolls to build the myriad-year clock. The key is this insect gear, so called for its appearance. And these other oddly shaped gears with teeth on only one side. How do these gears mesh? Driven by the spring, the gears with teeth on only one side make one complete revolution in a year. Here they engage with the insect gear. The insect gear turns one way when it's engaged with the gear on the left, and then the opposite way when it engages with the gear on the right. The to and fro movement of the insect gear is transmitted through all the other gears to adjust the spacing of the chapter marks on the dial. The myriad-year clock had an astonishing precision for its time, plus or minus a maximum of 15 seconds per day. This technical tour de force revealed the ingenuity that would power Japan's clock-making industry.
This is a clock and watch museum in Tokyo's Taito Ward, and they have exhibits here of a number of different types of timepieces, all dating back to before the middle of the 19th century. Here's another clock like the one you just seen in the video, except this one's just a little bit different. You notice if you look closely that it's got two balances here at the top, one that's moving and one underneath it that's not. And the reason why it has these two is one's for the daytime, one's for the night hours, and these switch over automatically, these gears in here. Now this clock even has an alarm system, so you can set it to wake yourself up in the morning. This is a 200-year-old clock. It sounded rather like this. And over here we have kind of Japanese-style pocket watches, except you wouldn't wear them in your pocket. The strap of this would be hooked into the sash of your kimono and you'd wear it on your hip. There were all kinds of clocks of this type produced in pre-industrial Japan, but then in the mid-19th century the country embarked on a new era of modernization and engagement with the West, and they decided to make their timekeeping methods conform with the rest of the world. The old style of clocks pretty much vanished after that, and Japan started to produce mechanical clocks of the same type that were used in the West. The next chapter in our story starts in 1913, when Japan begins to make wristwatches. Let's take a look now at how they develop.
Development of Japan's wristwatch industry was propelled by the Second World War. Military maneuvers on the battlefield required synchronized action by soldiers. For this purpose, senior officers were supplied with wristwatches. As the conflict widened, military wristwatches were produced in large numbers. After the war, Japan made wristwatch manufacturing a priority industry. Japan set its sights on a timepiece superpower, Switzerland. In 1950, the Swiss were making 25 million watches a year. Japan's production was just 700,000. Back then, some Japanese watches had an error of 3 minutes per day. There was a huge gulf in quality from the Swiss watches, which were accurate to tens of seconds per day. Japanese manufacturers, determined to increase the precision of their watches, turned their attention to a component called the balance wheel, which keeps the hand moving at a constant rate. The balance oscillates back and forth regularly, and a part called the pallet fork, to which it is connected at the centre, beats out a regular rhythm. The rhythm of the pallet fork powers a gear train connected to the hands of the watch, driving them around the dial at a constant rate. Watches in general tend to experience an error because they're sensitive to external shocks. The balance wheel must be able to withstand severe shocks, so Japanese watchmakers set out to enlarge it. The larger the balance wheel, the greater its stability of oscillation in spite of external influences. An R&D program was launched to make the largest possible balance wheel, while leaving enough room for other components. In 1960, this bore fruit in a watch with a 12mm diameter balance, 3mm larger than previous ones. It was accurate to within 10 seconds per day. Koichi Namiki is a university professor who teaches horological history. He says this watch caused a stir around the world. The market leaders felt very threatened that Japanese companies had made such progress in their capabilities. But the Swiss, meanwhile, had beaten Japan to the punch in developing a watch with better than 10 seconds per day accuracy. This was made possible by the merging of small family-run watchmaking enterprises that had previously made up the industry into large companies that tried hard to improve accuracy. Japanese manufacturers were determined to overtake the Swiss. So they launched a new technological development project. They turned their attention to the oscillation rate of the balance. Back then, in typical Japanese movements, the balance oscillated 5 or 6 times per second, causing the needle to cover 0.2 seconds with each movement. Japanese manufacturers greatly boosted this oscillation rate to 10 times per second. A balance with 10 oscillations per second moves the hand 0.1 seconds at a time. This would reduce errors even more. Here is Japan's first high-speed oscillating watch. It went on sale in 1967, boasting excellent accuracy. The number of beats per hour, 36,000, is proudly inscribed on the dial. But, unfortunately, the watch couldn't maintain this accuracy for long. Rapid oscillation caused excessive wear on the parts. Japan's watchmakers then turned their attention to making the parts stronger. After many struggles, finally, in 1969, a new watch was announced that had an error of only 2 seconds per day, and it was able to maintain that accuracy for 2 years. The world was astonished. That was the era when the mechanical timepiece reached its ultimate evolution in terms of accuracy. And so, Japan's watch industry had climbed up to contend on equal terms with the Swiss.
As you can see, I'm in a watch and clock shop. This one's in the Shinjuku area of Tokyo. The Japanese became able to compete with the Swiss in terms of accuracy, but for a long time the Japanese watch industry trailed by a long way in the area of production volume. For example, in 1969, Switzerland was pumping out some 55 million watches, whereas in Japan, production was less than half of that. It was a time when made in Japan, certainly with regarding to watches, just didn't have the same ring to it as Swiss-made. But then along came a timepiece which turned the whole industry on its head, the quartz watch, which of course is now ubiquitous. Japan was the first country to develop this kind of watch, which brought unparalleled accuracy and with it worldwide acclaim. It was quartz technology that turned Japan into a watchmaking superpower. However, the process was not an easy one. Let's take a look in detail now at the birth of the quartz watch.
The city of Suwa in Nagano Prefecture is located about 200 kilometers from Tokyo. Wristwatch production began here in 1942. It all started when Hisao Yamazaki, determined to make Japanese watches a worldwide success, opened a factory in the city. In 1959, word reached the factory that a quartz clock had been invented in the United States. Quartz clocks contain a crystal that oscillates at a fixed frequency when an electric current is applied. This was an entirely new kind of clock. The newly invented American clock was accurate to 0.01 seconds per day, but it also stood 2 meters tall. Yamazaki pondered how to cram a quartz clock into a wristwatch. Quartz clock technology was radically different from that used in mechanical clocks. The crystal oscillation was transmitted by means of an electric circuit and stepper motor to move the hand. Such engineering demanded electronics know-how. So Yamazaki scoured Japan for students studying electronic engineering and assembled a team of 20 young men in Suwa. Their long struggle to make the quartz wristwatch began in 1961. The first problem they faced was with the electric power supply. In order to make a wristwatch-sized movement, they had to miniaturize the crystal. A small crystal oscillates more actively, and that consumes more power. The battery would run out within 3 days. Then another setback struck. Yamazaki was diagnosed with stomach cancer. And he died only 6 months later. Having lost its leader, the project faltered. Then, in 1963, another bombshell hit the Suwa factory. Word that the Swiss had begun developing a quartz wristwatch. The young engineers decided to honor Yamazaki's legacy by continuing the development. But the miniaturization of the crystal remained a major problem. Kinji Fujita, tasked with the miniaturization, was at his wit's end. Then he noticed an object in a friend's room. A tuning fork used for tuning a guitar. Fujita was inspired to make the quartz crystal U-shaped. A notch in the crystal would dramatically extend battery life. Fujita immediately set to work and constructed the world's first miniature U-shaped crystal. Six months later, prototypes equipped with this crystal were made. The engineers took them to a gymnasium Wearing the wristwatches, they began playing volleyball. Wristwatches must be able to withstand severe shock. To be a legitimate wristwatch, the prototypes would have to endure this abuse. The engineers played volleyball for 3 consecutive days. But the watches continued to keep accurate time. In 1969, the world's first quartz wristwatch went on sale. It was 8 years after the R&D project was launched. It was accurate to within 0.2 seconds per day, tens of times better than any mechanical watch. It sold out instantly. All the hard work by Yamazaki and those who carried on his legacy finally paid off.
The quartz revolution of the 1970s dealt the Swiss watch industry a severe blow. In 1970, there had been 1,600 watchmakers working in Switzerland. That number was cut to a third. Then by the end of the 1970s, Japan got to a point where it was shipping about 60 million watches a year, claiming the #1 spot in the market. That was 30 years ago. In recent years, Swiss-made mechanical watches like these have been enjoying a resurgence in popularity. Not only are they more accurate than ever, but they also have a kind of luxury brand cachet that quartz just doesn't. However, in the headlong rush into quartz in Japan, the mechanical watch industry went into a steep decline, and most of the gains of the 1960s have now been lost. Let's take a look now at the current state of mechanical watchmaking in Japan.
Osaki Shimojima is an island in the Seto Inland Sea. A clock and watch shop here has been in business for 140 years. Keiichi Matsuura is the 4th generation proprietor. Matsuura receives orders for timepiece repair from all over Japan. They include broken pocket watches with no glass, wall clocks that are more than 100 years old, and timepieces that other shops have refused to even try repairing. Matsuura painstakingly repairs each one. A disassembled timepiece must be reassembled quickly to prevent dust getting in the mechanism. He adjusts the angle of screws less than 1 millimeter in diameter using a fingernail. The balance between the sensitivity and dexterity of my hands and concentration is the key. Matsuura has received letters from all over Japan. They all express people's love for their timepieces. I am energized by the letters and postcards that I receive after fixing people's timepieces. Mechanical timepieces are often important mementos for their owners. But the rise of quartz and digital timepieces has shrunk the number of experienced watch repair artisans like Matsuura. So a program has been launched to train artisans in timepiece repair. This special school is in Otsu, a city in Shiga Prefecture. Yasushi Sugimoto has been attending the school for almost 3 years. Why did he decide to pursue a career in timepiece repair? This was my grandfather's collection. These watches were treasured by Sugimoto's grandfather, who died in 2007. When Sugimoto was a young boy, his grandfather would sit next to him and teach him the magic of mechanical watches. I remember my grandfather winding the mainspring, and I'd look with him at the watch operating as he taught me how to read the time. Sugimoto wanted to make his grandfather's watches run again, so he decided to become a horologist. But it's no easy task. He has class 7 hours a day, and dealing with a world where 1/100th of a millimeter matters demands great focus. For example, this gear, just 8 millimeters across, must have 72 evenly spaced teeth carved into it. I want to repair my grandfather's watches, so I need to learn all the necessary skills. Then I'll go on to fix watches that are considered beyond repair at other shops. I want to save those watches. I want the owners to enjoy the thrill of seeing their watches work again. Sugimoto is only halfway through his quest, but perhaps his passion and that of his young fellows in the timepiece training program will bring about a rebirth of mechanical timepieces in Japan.
It's been more than 450 years now since the first mechanical clocks came to Japan. Along the way, the Japanese have rethought their method of measuring time. They've battled it out with the Swiss for precision and accuracy. They've propelled the world into the quartz age, and now young Japanese are starting to make and repair mechanical watches again. Who knows where the story goes from here? Japanese people tend to be very punctual, and when people ask me what I like about Japan, one of the aspects I always think of as being positive is that you can rely on things to run on time. And that reminds me, I better be off. I'll see you again next time.